For our last session. It's a pleasure to introduce Alexis WELLWOOD. It is not a pleasure to say that she's professor of philosophy and linguistics at the University of Southern California, because she was my colleague and she left us. But it's still a pleasure to introduce Alexis. Alexis has done a lot of work on comparatives. Alexis has done work on language acquisition. Alexis has done work on mass count and corresponding issues about object and substance cognition. And today, she's going to tell us about events in language and in mind.
Okay, thank you, Michael. So I'm really lucky to be near the end here because, especially today, it looks like most of the setup has been done for me. And in particular, I think that my talk can be read directly as an answer to Michael's question about what work events can do for us cognitively. So I'm not going to say any of that answer explicitly because it's not what I've prepared to do, but it should emerge, and if it doesn't, then you should ask during the Q&A. Okay, so I'm a semanticist, and I'm interested in the nature of meaning. I'm not, at least here today, interested, though, in debating whether we should think about meaning internalistically or externalistically or whatever. I'm thinking about it internalistically, but still taking a sort of traditional line that what meaning is a relation between linguistic objects and something else. And what I really want to do today is just kind of like explore this boxology, and you'll see what I mean in a minute. I want to give a boxology that responds to a particular kind of data, so let me introduce that to you now. So consider this very simple world, you might imagine. So there's whatever's on the left and whatever's on the right, and suppose I described what's on the left as ands, A's or ands. I'm probably going to say an all the time, hopefully, sometimes al maybe. But that's Anne's glebe on the left, and that's Bill's glebe on the right. And you know, you've never heard the word glebe before, but you can kind of think about what you might take it to mean, or what are the candidate meanings for glebe given this very simple world. So some of the things you might think is, well, you know, if you're imagining these as, you know, a kind of object, you might think metal or grayness or ring or circle, anyway, some things like that, and probably not many more, given how simple these things are. But now suppose I tell you, furthermore, that it's true that Anne has more glebe. So Anne has more glebe than Bill does, for example. Well, you might now be feeling like some of the candidate meanings are no longer possible. So in particular, metal's still available, grayness is still available, but probably ring or circle are out. So that's one kind of data point. I give you a little bit more information and the candidate set shrinks. Can I give you another example? So this is Anne and Bill and the English Channel. Okay, so this is my like staying up way too late to make this little graphic for you guys. So that's Dover and that's Capnay, Greece. This is the English Channel. I'm going to represent it abstractly like this. And now suppose here's what happened. There, it's Anne blicking. There she goes. Oh, and there's Bill blicking. You might have blinked and missed it, but it was fast, right? So here too, you've probably not heard the word blick before unless you've been to a language acquisition talk. But again, we might ask, well, what could blick mean, given these very simple goings-on? And you might think, well, I know it's the channel, and you know, maybe they were swimming, meandering across the channel, crossing the channel. Maybe, you know, I actually don't get the losing example. But again, suppose that I give you a little bit more information and I say that it's true that Anne did more blicking, or that Anne blicked more than Bill did. Now, again, here too, you might feel like some of the meanings that were possible for blick aren't, or they're at least strongly dispreferred. So sure, blick might mean swim here. It might mean meander, but it's not likely that it means cross, for example. So with just these kind of like simple data points, let me start filling out the boxology. So I'm thinking about meanings. Now this is me like giving Frege the finger, for example. But as a relationship between expressions and something like percepts or concepts, and I think Frege's term concept script or conceptual script is going to be appropriate for the way I'm thinking about the meaning part of this picture. So you'll see what I mean in a second. So the approach that I'm after is to mine formal semantics in particular for hypotheses about mental representation, whether we're talking about linguistic representation or representations in non-linguistic cognition. But I want to, in particular, as a semanticist, focus on what formal semantics in particular, or how it might help us hypothesize about those things. So what I think success would look like in this kind of approach is that we would end up with some better explanations for things like language learning, language understanding, cross-linguistic variation, et cetera. What I'm going to do today, more specifically, is use an analogy that's brought up in semantic theory all the time for decades, a particular semantic analogy to make some fine-grained predictions about conception. So predictions about a certain conceptual distinction that's not been explored very much, say in cognitive psychology, but I think that the semantic analysis is telling us about exactly that, and I'll let you be the judge. Okay, so the analogy is object is to substance as event is to process. Okay, what I'm going to be doing is, on the one hand, leveraging some linguistics, and on the other hand, some cognitive psychology, and of course, this formal semantics bit in the middle. The picture I'm going to set up is this thing that I've really only made to scare you, this thing here. So on the left, in the sort of linguistics box, we've got like whatever sound is doing, and then we've got syntax, more specifically in these cases, morphosyntax. And then on the right, we've got sort of conceptual domain and measures or estimations of quantity, thinking about quantities, things like that. And then this stuff in the middle is going to look like the lambda calculus. I'm thinking about, so for the specialist, anybody who's worried that I'm making some kind of category mistake, you can think about these as descriptions of functions in intension, in Church's sense, not as functions in extension. So the particular symbols that are used are taken to be important here. Okay, so this is what I'm going to set up, and broadly speaking, on the top of that arrow, the top half of that arrow, you've got the static domain, and on the bottom half, you've got the dynamic domain. And I'm going to use this as a guide, so we'll be picking out little pieces of it as we go along. Okay, so here's the plan. I'm going to talk about some semantics, just do some straight sort of semantics first, and then I'm going to talk about influence of language on sort of how we're thinking about things in a context. So in particular, as how we choose how to quantify given a world that makes many quantificational possibilities available to us. And then in the third part, I'm going to talk about influences in the other direction, so sort of how we're thinking about things influences the sort of language we use to talk about those things. And so that's going to be more about how we conceive of things. Okay, so we'll get started. So as Michael mentioned, I've done a lot of work on comparative, so this is my usual starting point. And what I'm going to do in this section is kind of flesh out this bit, or just sort of focus on these bits. We've got a set of nouns or noun phrases. I should warn you that I'm not always going to be talking about metal and crossing and swimming and so on, but like a good linguist, it doesn't really matter what the specific content of these little lexemes is. So these examples are going to stay the same, even though sometimes we might be talking about I don't know, soup or mud or something like that. But for now, I want to set up just these correspondences between these kinds of sounds that we hear and these kind of intuitive conceptual domains, and then in particular, how we invoke measures in comparatives. Okay? So let's go back to this example. So hopefully you'll get a feel here for why your intuitions might have shifted around in the case of the novel noun. It's considered a problem in semantics and philosophy of language and so on that we can describe like one and the same thing in very many different ways, and often the description that we choose can suggest things have contradictory properties, etc. I'm not going to worry about any of that today, but let's consider this world again, and suppose that what you're looking at on the left can be equally well described as Anne's medal or Anne's ring, and the same thing for Bill. When you put these known nouns in the comparative, the medal noun is perfectly fine here, right? So Anne has more medal than Bill does. That's perfectly fine. You know exactly what it means. But Anne has more ring than Bill does is kind of odd, right? You can reach, you'll find a thought eventually, but it requires some work in a way that the first sentence doesn't. Okay, so same sort of thing in the dynamic domain. So we can describe what happened on the left as Anne's swimming. I guess I should have mentioned, I want them to be swimming, okay? So they swam, and it was a crossing the channel. So we can equally well describe the activity that's depicted statically here as Anne's swimming or as Anne's crossing, and the same for Bill. But now in the verbal comparative, it's perfectly fine to say Anne swam more than Bill did, and here, my representation here is meant to make you think that this is true, but it's odd to say that Anne crossed more than Bill did. There too, you might, reach and find a thought eventually, but it's not obvious exactly what that's supposed to mean in contradistinction to the first sentence. Okay, one more of these. So now we've got this situation. Now suppose what's on the left is Anne's medal, but we could also call them Anne's rings, and the same for Bill over there. Despite being able to describe these things using, say, the mass noun medal and the plural count noun rings, you get distinct truth values when you embed these things in the comparative. So first, they're both fine in the comparative. Anne has more medal than Bill does, and Anne has more rings than Bill does is fine. But in this context, just take my word for it, with my little PowerPoint tweaks, Anne has more medal is false, and Anne has more rings is, well, clearly true. Okay? And in particular, what seems to be going on, why the first is false and the second is true, is because, let's take volume, there's other possibilities, but the volume of Anne's medal is not greater than the volume of Bill's medal, but indeed the number of Anne's rings is greater than the number of Bill's rings. So when you see these little formal bits, I'm going to be using the double variable names for pluralities. That's the difference there. Okay, same thing over here. So it's fine to say Anne swam more than Bill did, again, in this kind of context. Now all of a sudden it seems perfectly fine to say Anne crossed more than Bill did. And here too, so we can use both of these sentences to describe these situations. It's just that if we describe it in terms of swimming, the comparative is false. And if we describe it in terms of crossing, it's true. Right? And so here, again, for the first one, I'm just sort of picking one of the available dimensions. The first one seems to be true false, because the distance that Anne swam is not greater than the distance that Bill swam, but it is true that the number of crossings that Anne did is greater than the number of crossings that Bill did. Okay, so in sort of my theory of comparatives, but you don't actually need my theory. When you're talking about nominal and verbal comparatives, so things like more noun and verb more, they're sort of, according to Chris Kennedy, one game in town. My theory gets controversial with adjectives, but I'm not going to talk about that today. But the way the theory works is that the dimensional selection, so which dimension you choose to evaluate these comparatives along for their truth or falsity, depends on the kind of thing that you're measuring. And in particular, the way it's structured. Okay, so that's about the interpretation. Now, whether the comparative is acceptable depends on whether the thing you're proposing to measure is structured in the first place. So what do I mean by that? Well, this is going to be fleshing out these interpretive bits here. Okay, so what you'll notice about these sort of functional descriptions is that in the first case where we're talking about a bare mass noun, what we have is a function that takes x's, whatever, to say to x is m, x is metal, and there's nothing else really going on there. You're just a simple property of whatever is metal. But as you get a little bit richer, I'm not going to argue for these syntactic representations, just believe me, there's evidence for it. And as Chris was pointing out, a good deal of it is cross-linguistic. What happens is, in the count case, you end up in a situation where you're restricted to considering atoms. I'll show you what that means in a second. And then in the plural case, you're talking about pluralities of things which bottom out in atoms. Okay, and this is what is going to determine dimensionality. So what do we mean by structure, and what does this stuff mean? Well, if we consider mass nouns and at-like verbs, so that's going to be like metal and swim, what we have is what we call divisive reference, so focusing on this bit. Okay, so what does that mean? So let's consider these guys again. So we've got now, we're looking at this as metal on the left and as swimming on the right. Let's just think about ways of dividing this stuff up and ask ourselves whether the term still applies. Okay, so I'll draw red boxes around the things to indicate success. That thing falls under the term. So certainly if you take the entirety of what's on the left, it's metal. And you take the entirety of what's on the right, it's swimming. But you can arbitrarily divide this stuff up, and you'll get more instances of the same, right? So just take arbitrary cuts, metal, 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 you know. So it sort of goes down as far as you like. You cut the stuff up and it's metal. Similarly with the swimming. Divide the swimming up, you get more swimming. So that's the mass noun. Anything that counts as metal is in the extension, et cetera. Okay, now in contrast, singular count nouns and singular telic verbs, these are the ones that we call atomic. They not only fail to show divisive reference, they are non-divisive. Okay, so this is what it means to be an atom. Okay, so let's look at these guys again. Now we're thinking about what's on the left as a ring and the thing that's on the right as a crossing. Now certainly the entirety of what's on the left is a crossing, and the entirety, or sorry, a ring. And I like to pause after I make a mistake like that because it feels like it gives you time to wipe it, erase it. And certainly what's on the right, the entirety of it is a crossing, but you try to play the same trick where you divide it up into arbitrary bits, and you do not get things that fall under the same description, right? So arbitrary subparts of the ring are not rings, and arbitrary subparts of a crossing of the English Channel is not a crossing of the English Channel. Okay, so you have to take the whole thing. That's what falls under the description, and none of the, at least in general, arbitrary subparts don't. Okay, now what's different about plural count nouns and what some of us think about as plural telic verbs is they show divisiveness. So there's some structure there to what these terms apply to, but it's limited, right? So now I'm fleshing out this bit. This says, you know, let's read it extensionally, a property of pluralities, every atomic part of which has the property of being a ring. So let's look at this plural case. So we've got the stuff on the left, that's Anne's rings, and we've got the stuff on the right, that's Anne's crossings, or, you know, we might describe it as Anne crossed again and again, and play the same game with the divisions. And certainly you take the entirety, you've got rings on the right, take everything, you've got crossings. Some ways of dividing this stuff gets you more instances of the same. So if I draw boxes in particular around each of the rings, then I have rings, or, you know, pairs of rings, et cetera. And same with the crossings, get the individual crossings, get pairs of crossings. But if I try to take arbitrary subparts of those things, they don't fall under the same description. Right, so I can't now start carving up the rings, you know, dividing a ring in two, and each of the parts counts as a plurality of rings, right? So limited divisiveness. So hopefully, I'm seeing in my advanced slide that I didn't say this explicitly, what you can see is that what determines, well, at least the way some of us have explained it, what determines the acceptability of a comparative with a noun phrase is whether or not it shows the kinds of structural relationships that we see in the successful cases. Like the mass noun shows divisive reference, the plural count noun shows limited divisiveness. Those guys are fine in the comparative, but the atomic guy is not fine. Right, so the semantics of more is sensitive to the structure of the things that you're comparing. Hopefully you could also see that the choice of dimension goes along with those structures. So for example, you measure the metal by volume or by weight. You measure the swimming by the distance or the duration. And that plausibly has something to do with the fact that the former is a substance intuitively, and the latter is a process of some kind. Right? So you don't measure substances for their duration or processes for their weight, et cetera. Okay, so the picture of the semantics of comparatives sets up the expectation that our knowledge of the grammatical property, fine-grained grammatical properties should predict how we quantify using expressions like more, right? Okay, so let's look at some of the work that's been done on this in the nominal domain. So how sort of morphosyntax, for example, in particular, can guide you towards certain dimensional choices. Okay, so I'm looking at this kind of chunk of the scene here. I failed to start my timer, so I have no idea. Am I going really fast or fine, or I have no idea how much time has passed? I have been going for 15 minutes? Okay, thank you. Okay, so for example, say I put you pretend you're a subject in an experiment, and you're presented with a world like this, and you're asked who has more blick. You could interpret that as some kind of, unusual plural form, but you probably won't. You'll probably think of it as a mass noun. Or, if you were asked who has more blicks, you'll recognize that as a plural noun. The expectation of the kind of theory I just set up is that definitely in the latter case, when you parse this thing as a plural noun, you should quantify by number, because you're dealing with a plural, I don't want to say extension, but, and this is exactly what happens. So Barner and Snedeker in 2004, they presented participants with little worlds like this, stuff that could be talked about in multiple distinct ways, and asked the who has more blick question or the who has more blicks question. And what you get from the who has more blick question is an understanding of the sort of default preferences for how people want to quantify whatever they're thinking about the blick. And then you get to see whether, if you add the plural morpheme, the preference shifts. And that's what you see. So in this graph here, you've got data from 3-year-olds on the left, and you've got data from adults on the right. And the gray bars are the mass question, which is more blick, or whatever you need. And you can see that, is that right? Yes. So they're plotting number-based judgments here. So how many of the responses to the question depended on number when the two dimensions were opposed to one another. And indeed, you can see that when people were asked who has more blick in little worlds like this, they preferred not to think about quantifying by number. But when you ask them the more blicks question, their preference flipped, right? So now they are answering the question based on number. Okay, so we see here a sort of default substance kind of interpretation of blick, which, when you throw the plural morpheme on there, shifts you over to a plural kind of interpretation. Now, this talk is really about the dynamic domain, and we can't construct a direct parallel of this experiment in the verbal domain because we don't have a plural morpheme, explicit, overt plural morpheme in the verbal domain in English. It's been argued that some languages do have this. So if I could ever get my hands on speakers of such a language, there's a very clear prediction to be tested here. But we can construct a sort of similar test with deverbal nouns. Okay, so let's look at this. Oh, I just made this table this morning, so like I have to parse it the way you guys do. So what's going on here? So now I'm talking about a study from Barner, Wagner, and Snedeker. And what they did was they took verbs that were intuitively sort of punctual, so describing sort of eventy kinds of things like clapping, versus durative verbs, so ones that are sort of more processual, like dancing or swimming or walking, etc. And then took the deverbal forms of those, so like clapping, dancing, like do some dancing, do some clapping, for example, and the plural forms of those, like do some claps, do some dances. And the prediction was that what they were interested in here is if you have the more eventy verb and then you nominalize it and you put it in mass syntax, you should get a continuous measure in the comparative. But if you take an eventy verb, put it into nominal form, mass syntax, you should get number, right? So the same kind of pattern as we were seeing before. But then, of course, if you have the plural form of either, that preference should be for number in both cases, uniformly, however you were thinking about the clapping or the dancing in the default case. Now, what they did was they would give participants sort of a text-based questionnaire. So the example they gave from the paper, here's the lazy copy-paste, this is the one that they give, so I'll give it to you. It's Jerry and Jake both clapped enthusiastically after the concert. Jerry clapped 1 time per second for 120 seconds. Jake clapped 1 time per second for 90 seconds. Overall, who did more clapping? Oh my gosh, I just realized I hope that wasn't a real item. If you guys see it, good, but if not, I'm not going to get into it. But the idea is that you will pit number comparison against duration comparison. And if you're dealing with a deverbal eventy thing, you should choose to answer the more question based on number. But if you're dealing with the more processy kind of thing, you should answer based on duration. So the question then is, who did more clapping? Or who did more claps? You can imagine the dance version. Okay, and here's what they found. So again, plotting the proportion of quantity judgments based on number. On the left, you have the event NPs, so things like clap or jump, et cetera. And on the right, the sort of process NPs, so things like dance. And again, in gray, you've got the answer to the mass question, and in black, the answer to the count question, the plural count question. And what you can see in the case of things like clap, you like to answer based on number, whether you're asked about clapping or about claps. But in the case of dance, you prefer not to answer based on number when you're asked about dancing. But of course, when you're asked about dances, you prefer to answer based on number. Okay, so your preference shifts. Okay, so we see that this sort of, little teensy bits of language changes quite dramatically how you quantify. So we want to know about VPs, though, right? So, of course, there's an intuition that these kinds of verbs traffic in event or sort of process kind of notions, but still, there we were using the nominal comparative, right? We might want to know how do things work out with the verbal comparative. Okay, so in particular, we want something like, we want to be able to ask the verbal question, who verbed more? And the idea is that if V is processual, then we should get continuous dimensions. I'll give you a hedge in a sec. And if V is eventive, then we should get number, right? Okay, so here's the hedgy bit. If you have a process verb in this kind of construction in English, there's actually two syntactic derivations that are possible. I'm not going to argue for that right now. But there's the bare verb one, and there's the one that has this additional functional structure. It's available, but it's just quiet. And so the idea is that just like you can have some mud, mass, singular, and 3 muds, you can have parallel derivations in the verbal domain, but you don't hear the difference. So Anne slept a little last night would be an instance of the bare verb, and Anne slept 3 times last night would be an instance of the pluractional verb. Okay, so the expectation for a process verb is actually that in this kind of verbal comparative, number is available, and it would be due to a different parse. Okay, so how do we distinguish in some kind of way that's not just our intuitions going into it, the eventive from the processual? Well, one thing that we can do is we can stick verbs in a kind of grammatical context that requires, well, basically non-singular interpretation. So like Anne verbed all day. If if the interpretation you get of that is of a series of discrete iterated goings-on, then we will say that the verb is eventive. If, maybe that reading is available, but it's not super strong, so if you sort of get weakly iterative interpretations for this kind of sentence, then we'll say that the verb is processual. Okay, so this is what we did. This is similar to what Barner and Snedeker did, but, well, different enough. So we've described to participants, this is on MTurk, iterative verbs describe happenings that must repeat if they unfold over an indefinite period of time. Durative verbs describe happenings that needn't repeat if they unfold or over an indefinite period of time, right? So it can just sort of like be this sort of ongoing, continuous thing. And then we just give, one verb at a time, and we tell people you could say, Anne verbed all day. And see what's the interpretation you get. So give people a verb and say, is that verb iterative or durative? Press like D for durative and I for iterative or whatever. So we tested 213 transitive verbs in this way, 30 participants, and this is what you see. So this is plotting the verbs by the proportion of iterative choices. So if you're higher up, that means you were preferring to think of that verb as necessarily iterative in this kind of V all day construction. And then if you're lower, less so. So we'll think about the eventy verbs as the guys up high there, and the process verbs as the guys down low. And so what you get, this is just like plotting the verbs by their name. And I've highlighted some of them for you. Jump is all the way at the top there. Walk is all the way down at the bottom. And then you get some stuff like glimmer in the middle. And think about it, or well, the box, or I don't know what glimmers. The magic soup glimmered all day. You know, it's like, well, is it repeat? I don't know. So you get stuff in the middle. An interesting sort of thing for data junkies out there is this is plotting the proportion iterativity by reaction time. And what you can see is that as you're sort of equivocating on whether it's iterative, you're also taking a lot longer to make the judgment. So that's what this sort of sweep is all about. Okay, so we're taking these sort of what might look to you just like lexical preferences as telling us something about the grammar of these things, right? So the comparative requires either, let's just put it structurally, the bare verb or the pluralized verb, the pluractional verb. So now we can use our event verb and our process verb in the verbal comparative and see whether the choice of the verb determines how you quantify given one and the same scene, so given multiple competing dimensions for comparison. Okay, so this is work by my student Haley Farkas. So we're looking at this corner of that weird thing, right? So this alignment. Okay, so here's what Haley did. These ones aren't, I think the animations are on the next screen. That's kind of silly. Basically what you have are identical sets. Actually, I'm just going to go there. Identical movement parameters. So we manipulated 3 dimensions, so number, duration, and distance. So discrete, 1 discrete, 2 continuous. At 3 different magnitude levels, all sort of matched for a ratio. So each comparison would be at least as easy as each other, so the same sort of magnitude comparisons. And here's what it looks like. So it's the same movement patterns. We just changed the background to make describing these things in terms of jump or move a little more felicitous. So this is the star does some stuff. Heart does some stuff, right? So, you know, if you were just looking at these scenes, it's kind of like the crossing of the channel that we saw at the beginning. You could think about like the height of the jumps, you could think about how long they spent jumping, you could think about the number of jumps, et cetera. And so what we're interested in is if we describe what's going on, if we ask you of these scenes, one and the same scenes, who jumped more versus who moved more, we expect different dimensional choices as a function of the verb. Now, we only expect that for the bare comparative, so just when you just get who jumped more. If we asked you who jumped more times or who moved more times, you should answer based on number, right? The adverbial is telling you the dimension explicitly. You don't have to figure it out based on the grammatical context. And similarly for who jumped higher. Nope. Yep. Okay, so here's what you see. So I'm plotting the proportion consistent with a given interpretation. So in this case, it's number consistency. So on the bottom, you have the responses for who jumped more times. And then the left panel is jump, the right panel is move. And what you can clearly see in the control case is that whether you describe it as jump or move makes no difference to quantifying by number. So you're totally consistent with number in both cases. That's what you see in the bottom box. In the top box, you can see that your responses for jump more are much more highly consistent with number than they are for move more, exactly as we would expect, right? Jump, event verb, jump more, it's about number, move, process verb, so you get to equivocate. You can think about number if you want, but you can also think about other stuff. What other stuff? Well, it turns out nobody was thinking about duration here, but they were thinking about height. So now we do the same, we're plotting the same data, but we're plotting it as a proportion of consistency with the height dimension. And what you can see is jump goes way down and move goes up. So indeed, Haley probed these data in a million different ways. It doesn't seem like a given individual picked number or height, like people were just sort of like, yeah, sometimes number, sometimes height with move, but they were always number with jump. And of course, the controls, who jumped higher, who moved higher, or whatever, exactly the same, totally consistent with height. I should mention there was 33% overlap in dimensional agreement here. So the 33% that you see for jump, that's actually just the proportion of time that height overlapped. The consistency with height overlapped with the consistency with number. So we have no evidence here that people were ever thinking the higher thought with the jump sentence. Okay, so what about kids? I'm going to use the kids study to motivate the next, and I think last section of the talk. So with the kids, so we tested 4.5-year-olds. There's a lot of variables here, right? Kids seem to get verb semantics later than noun semantics. So in order for this to be a good test of their knowledge of the verbal comparative, we're going to depend on them having the correct semantics of the verb, et cetera, et cetera, et cetera. So what we did was we took a subset of the sort of parameter sets that defined the trials in the previous study, and instead of geometric shapes, we've got monkeys, and we're using jump and walk. So the monkeys are going to be going up and down on the screen in the jump case, and they're going to be going side to side in the walk. Do these move? Oh, no. But otherwise, the number of times they move, the distance they go, and the amount of time they go, et cetera, is the same in both the cases. The reason these are so different is that we wanted to do within subjects here. We thought it would be more impactful to know whether kids within a child, they made this distinction between eventee and processee. So we wanted the things to be different enough that they would feel like it was something different. So this was played on an iPad. So we'd like open up an app, and it's like, okay, now we're gonna play this game with monkeys, and then when you're done, you like close it up and like, you wanna play another game on the iPad, and then you open up this other one. And so we wanted them to be as different seeming as possible. And otherwise, the questions that were asked were the same. So we did verb within subjects and sort of comparative quantifier between subjects. Okay, so here's what we find. Sorry that these plots aren't arrayed in the same way. So you've got jump, the results for jump on the left, and the results for walk on the right. And the dark bars are the control responses. So in this case, we're looking at the number consistency, so the proportion of responses consistent with the number dimension. And then the light blue bars are the responses for more. And what you can see is that the responses to the who jumped more times, who walked more times, is the same, regardless of jump or walk, but also not super great. They're above chance, statistically, but they're the same. Okay, so the controls here, the ceiling performance on numbers not that great with these 4.5-year-olds. And more worryingly, the difference between jump and walk with bear more is no different. Right, so the light bars are the same here too. If these kids were adult-like, if these kids were adult-like, we should have seen this pattern in the light blue bars. Okay, and that's not what we're seeing. So we're not getting the verb effect with the children. If we plot the data as the proportion consistent with height, it actually looks like for both jump and walk, they're preferring to answer based on height. Right? So again, there's no difference between the verbs, but their responses are consistent with height at above chance levels. Okay? So we think that, I'm not going to motivate this explanation, but we think that the kids are responding just based on the visual features of the scene, not based on their knowledge of the verb semantics. So we're testing that now in the sort of Sue Carey 1978 way by doing the Who Blicked More study, right? So no lexical content. What do we expect? Exactly these data. Right? So exactly the pattern of if you have no lexical information, what do you do? We expect the same thing, so I'll report back later. But if that's true, if kids are judging these sorts of scenes on the basis of the scene, well, we should probably know what makes a scene event-like, or what makes a scene process-like, right? And it turns out there's not a lot known about that, so that's what we're going to look into now. Okay, so in particular, looking at this guide, I hope this is the last time you see this guide. I think it is. In particular, we're going to be looking at what makes the difference of an atomic property, right? So we've got the kind of interpretation we associate with metal doesn't say anything about restriction to atoms, but the kind of representation that interpretation that we associate with rings does involve this notion of atomic reference. So we want to know what makes the difference of an atom. And we want to know what that is both in the static domain and in the dynamic domain, because hypothetically it is in fact the same property. Okay, so given this atom of X in the static domain or atom of E in the dynamic domain, we looked at this building on, people are fond of reminding me that this goes back to Aristotle, but I'm going to attribute it right now to Prasada et al. 2002. Okay, so the way they described it, building on a long philosophical tradition, is that what counts as an object is something that is the result of shaping forces, or it's something that we perceive to have been the result of some purposeful arrangement of matter in a certain way. So that's what distinguishes a pile of sand or a pile of clay from a statue or whatever, right? Is the shaping quality of the statue differentiates it from a pile of mere stuff. So the form of the thing is at least partly constitutive of what it is, okay, modulo science fiction scenarios, et cetera. So why don't we just sort of like think about this notion of the shaping or the form being integral to what it is to be an object via this notion that atomicity is shared across domains as also characteristic of what it means to be an event. That's the way we were thinking about it. And so what we want to know is whether similar factors that will make you classify something as an object make you classify something as an event. Okay, so I wish I'd put the Prasada stuff up here so you could see. I'm just doing his method, but in different ways. Okay, so first, this is joint work with Sue Hespos and Lance Rips at Northwestern. So the first thing, thinking, okay, well, suppose you take some stuff and you divide it up in a way that appears to us as non-arbitrary. Like the stuff has been divided for some purpose or in a principled manner, so in a natural fashion. Does that cue you to atomicity, and does it cue you in the same way in the static and dynamic domains? So here's what we did. So the method, again, is coming from Prasada, so it's a forced choice linguistic task. We're going to present you with a picture or an animation, and then we're going to ask how you'd prefer to describe what you see using a novel noun embedded in either mass or count syntax. So what we did was we drew, using MATLAB, these sort of flower-type shapes with 4 through 9 petals, and then cut them up in different ways, either in at the joints, so at the center, in the case of the natural images, naturally divided images, or at arbitrary points along the path in the case of the unnatural images, and then just sort of scattered them around the scene. So the thought was the ones on the left would be good candidates for plural reference, in which each of the little thingies is an atom, and the guy on the right would look more like, scattered stuff, right? Scattered line drawing, not a good candidate for plural language. So present these images to people and ask them to choose whether they'd like to describe what they see as there are some glebes or there is some glebe. Okay, so plural, atomic reference, mass, no such implication. And the prediction should be clear. Now, what we did in the event case is we just, exactly as Jeff was telling us about the, McGuire et al., just animated an entity along the paths that corresponded to those images. So you can't see the paths, but you can see the thing moving. So there's a little star. Okay, so it's going in little loops, right? Versus an unnatural case. So I don't know about you guys, but I feel the difference when I see those things. It looks like the guy's just moving around and incidentally stopping, so there's sort of incidental interruptions in a meander, whereas on the left there's something structured happening. Okay, so what happened? Well, here I'll be plotting the proportion of count syntax choices, so the glebes as opposed to glebe. Oh, I should have drawn your attention to, in this case, we used the D-verbal nominals like Barner et al., 2008. So they're choosing between do some glebes and do some glebing. So I'm plotting the proportion of glebes choices, count choices, atomic choices. And what you'll see is the natural conditions in black and the unnatural conditions in gray. And so for the images, what you see is overall the sort of geometry that you'd expect. The naturally divided images, people are selecting the count syntax at far greater rates than they're selecting the count syntax for the unnaturally divided displays. Now, it's not a categorical difference, right, in which case you would have seen the gray bar be far below chance, but the overall geometry is what you would have expected. Now, crucially for us, what happens in the dynamic domain? Well, the categorical difference, right? So people are choosing, let's compare them side by side, people are choosing the count syntax at about the same rate in the dynamic domain as they were in the static domain, for the naturally divided conditions, but they were choosing the count syntax at even lower rates in the dynamic conditions than they were in the static ones. So the overall pattern here is exactly what we would expect based on the analogy that the semantics sets up. And in particular, the idea that the shape of the thing is what's determinative of atomicity. Okay, now, what I just showed you are the results that sort of go for broke, right? The natural divisions. But what about a weaker notion? And this was actually the weaker notion that, for example, Prasad et al. Talk about. It's not about naturalness per se, it's about whether the structure is arbitrary or not. So we tested this by using exactly the same paradigm, but instead of carving the flower type thing up, so that you get petals, you carve it up the same number of times, but you start at a random position, right? So on the left here, we'd have, like, say, the non-arbitrary images, and on the right, the arbitrary ones. Okay, and everything is exactly the same. How do you prefer to describe these scenes? Count or mass? And what you find is exactly the same pattern, right? So the carving it up into loops or petals or whatever, it didn't matter. You get the proportion of count syntax choices, again, is higher for the non-arbitrary than for the arbitrary. You did lose some of the, let's say, probability mass in the animations non-arbitrary, but I'm not going to read too much into that. Okay, so that's interesting, but then you might wonder, well, I don't know, is this really about the arbitrariness or non-arbitrariness of the form, or is it something about equal contours, some really, really boring sort of task-specific effect? Like, it's just the fact that the guys on the left are all the same length, path length in the case of animations, or line length in the case of images. So that's easy to test. We take the same images, but we divide them up a different number of times, right? So instead of dividing the flower, the 4-petaled flower, let's say, into 4 parts, we divide it into 5, but we just make sure that we cut the same length in the equal contours condition, am I describing this correctly? Oh yeah, right, so you make sure they're the same length in the equal contours case, and then you don't worry about the equal length. You let it vary in the unequal contours case. And what do you see? Well, in the case of the images, finally, we failed to extend the result. So here, you don't see more count text choices for equal contours than you see for unequal contours. In fact, you see, if anything, the opposite pattern. All right, so the effect goes away. Merely having the same amount of line stuff, or instantiating the same amount of line stuff, is not important for this distinction. Okay, what about the dynamic domain? Well, here actually, we've lost yet more of this sort of probability mass, but we do actually see the same geometry here. So we're not flipping things here. So this is the 3 experiments altogether. So what does this sort of suggest? Well, it suggests something that we've already heard today, that the spatial shape matters when you're thinking about objects, but it's the temporal shape that matters when you're thinking about events. Because, of course, in the equal contours condition with the dynamic, in the dynamic domain, the amount of time that the thing moves in each thing, each going on or whatever, it's the same amount of time in each case, but the path traverse is not. Okay, so neat. I don't have much time, but I couldn't resist just showing you something that's that we're getting into right now that's related to this. So trying now to link up in particular with, say, Jeff's type work, so thinking about how this stuff about arbitrary divisions and so on interacts with notions of event segmentation. And so this is my student Haley again, and I asked her for a certain set of graphs yesterday morning, and she started working on it when she woke up. That's 9 hours difference with LA. And when I went to bed last night, I answered some questions she had about it. And when I woke up this morning, she was still working on it. So even if I run over time, I have to talk about it because it's not fair to her if I don't, okay? And it's cool. Okay, so what we did was we were looking at, we just wanted to see if we could isolate some very event-y scenes versus some very process-y scenes. And in particular, sort of categories or types of scenes that would differ in the size of the perceived event. So we're thinking about things like, how a jump is like an up and a down. Can we get guys that are I'm an event that is just like a 1. Can I get one that's like a 1 and back versus just a sort of ongoing process? So check out these 3 types that we sort of intuitively came up with. This is the one that we called constant movement. So like the graphic below is meant to sort of remind you later, here what you just have is this object moving at a sort of constant speed back and forth across the screen, okay? So this is the constant movement pattern. This one's my favorite, I think. I think this is the one. Smooth movement, we're calling it, but it looks to me like electromagnetism or something. Like, wow, wow, right. So I was thinking this would be a good candidate for carving the minimal units up into a back and a forth, versus sharp, which this one gives me nightmares. Like, there's something weird about that, right? The velocity changes are as in the little schematic below. Okay, so whoa, whoa, whoa. Okay, so what we did was, within subjects, we presented people with these 3 movement types in different blocks. And we had different numbers of back and forths that each of them would do. And between subjects, we inserted either arbitrary pauses in the activity, or in what was going on, or no pauses. So there's a pauses versus no pauses condition. Right, so we're just exploring, what are people thinking about these things, and how does this notion of arbitrariness interact with it? So we asked 2 questions. We'd show them the scene, different numbers of back and forth, et cetera, different movement types. And the first question was, what happened? So just describe it for us. And we're using neutral language. We don't want to bias them in any way towards thinking about any particular thing. Just what happened? And then the second question was, how many times, right? So get a count, and that'll tell us the grain size that they're thinking about. So I'm just going to give you a little sampler of the data. So for what happened, this is crazy. 84% of all the responses contained either bounce or move. Like, I don't mean variance on bounce. I mean bounce or move. So 2 verbs were produced in these free-form responses across, I can't remember how many subjects we had. I think it's in the order of 60 or 70, again on MTurk. Bounce is an eventive verb, so 28% of those, of all the data contained those, and processual move about 56%. And we didn't get any difference by movement type here, looking at this kind of measure. So we did not get any kind of sorting of the movement patterns based on a venti verb or processy verb. So that's what you can see on the right. So the proportion of responses that contain, right, so you can see the bars are flat. Okay, so whatever intuitions that we have about these different movement patterns are not translating into the choice of event or process verb. Check this out. Split it by pauses, no pauses. Okay, so again, we've got the data for bounce on the left and the data for move on the right, and the dark bars are no pauses, and the light bars are pauses. And what you can see in the bounce case is when you have no pauses, people are using bounce a lot, right? So when you don't have these arbitrary breaks in the goings-on, people are choosing the event language more than when the arbitrary pause is there. Why might that be? Well, because, I don't know, arbitrary pauses makes it look like you've just got interruption in an ongoing activity, something like that. In the case of move, you have, does this make sense? More use of move with pauses than without. So yeah, it's exactly the same thing. If you were already thinking in the move direction, you are more likely to think that way with the arbitrary pauses than without them. And this is like crazy huge effect here. Okay, how many times? How does this interact with the segmentation pattern? So this is the stuff that she spent the entire day yesterday generating. And it's complicated, so I can't possibly go through it all right now, but I just chose a sampler. So I picked the constant movement pattern, which is the one that we thought would be the most processy, because nothing's changing. It's hitting the wall, but other than that, like it's just, there's no changes in velocity, et cetera. And what you have in the left graph is counts of back and forth units. So for example, if the guy went like this 16 times, then you might produce something like 8, right? So you're counting a back and a forth as 1. And then on the right, you have the total crossings. Okay, now these are split by pause, no pause, and it's the, so the proportion of the responses that gave that kind of count, the back and forth count versus the total crossings count. And what you can see in the constant movement case, and this is just for move descriptions. So when people said move, this is what happens. With constant, there's no difference between the pause, no pause. Okay, so whether you're talking about counting back and forths or you're talking about counting the total number of crossings, so saying 16 in the example I gave, no difference here. But if we look at the bounce descriptions, huge difference. So the counting back and forth cases for the same movement pattern, constant, you're getting more counting of the back and forths in the no pause condition. Is that right? No, let me see my screen. Sorry, in the pause condition. So in the pause condition, you're getting more counts of back and forths than in the no pause condition, and then the opposite pattern in the case of the total crossings. So I don't have time or bandwidth to explain what's going on here, but you can see that there's a massive difference and interaction between how you're thinking about the thing and how you're quantifying the thing. And this is different for each of these three movement patterns. So ways of looking at this data will show you no effect. Like Haley was depressed for months. This was her first screening paper. It was like nothing was happening. But as she kept poking at it, I was like, oh my God, once you start splitting it by the pauses, everything starts coming out. That just wasn't the way she was approaching the experiment in the first place. She was thinking about the intuitive category distinctions between the scene types. Okay. So to conclude, this is just a case study trying to think about meaning as this kind of relationship between morphosyntactic representation on the one hand and these sort of conceptual domains on the other. And I just wanted to finish on kind of hopefully giving you a sense of how this exploration helps us to understand the sort of novel data, novel noun, novel verb data that we started with. Okay, so in the case of, if you just have simple lexical roots, let's say, there's a sort of freedom in what that thing can relate to, right? So here I've got like whatever, gloop and borrel, and then I've got like some sentence stream. If you hear, I'm imagining the Peanuts voices like, wah, 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 some gloop is, wah, 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 he borreled all day. Like, so you're hearing these novel things in a certain grammatical context, which tells you what the syntactic structure is, which of course is going to tell you what the sort of concept script is like. So in this case, you're just going to have some property, individuals, events, who knows, alpha, and you're going to have to figure out how to associate those lexical roots with concepts. You get restrictions in what sorts of concepts can be paired with once you've got a little more structure, a little more composition. So if you add these little singularizing morphemes, counting, or atomizing, whatever, once you get that restriction to atomicity, now you're going to be thinking object, you're going to be thinking event. You can't be thinking substance or process anymore. Exquisite's a strong word. Throw the plural morpheme on there. Again, you hear it in a different context. You've got quite a lot of restrictions there, right? You know, plurality of things that bottom out of atoms. So I think, hopefully, that helps to explain the original observations. Thank you.
We have a couple of minutes for questions.
So Alexis, I was really excited to see the experimental work. I had questions about both the previous set of experiments and then the new one. Oh, I guess the new one is just an observation. So if people observe something going back and forth at a constant rate of speed, it doesn't actually look like a constant rate of speed. So to move your hand back and forth.
I agree with you.
Yeah. Well, and so there's this 1/3 power law scaling, so that basically as you get close to the ends, you have to slow down and then you speed up in the middles. And so if you animate with that, then people will think that it's constant, and that would be an interesting comparison to throw in.
No, that's actually a really good point. I'll pass it on to Haley because she felt very strongly that these manipulations should have the effect they should have, and you know, she was reading some of your work, et cetera. So
cool.
Definitely will do.
And then the question about the previous ones was, it wasn't totally clear to me in the control conditions, or in the basic comparison.
This kind of stuff?
Yeah, and then in the previous one, is the similarity within each set equivalent? Like, so in the basic one, right, the different objects, when they're naturally cut, are more similar to each other in contour than the collection of objects when they're arbitrarily cut. And do the controls equate that along the way?
Okay, wait, what do you mean by controls here?
So like, go forward to the, oh, no, sorry. Back.
Oh, you mean these other experiments?
Yeah, exactly.
Yeah, so no, are you asking about the shapes? How they
So
look
like, to
kinda
me,
different?
the ones on the
Yeah.
left, those 4 look more similar to each other than the 4 on the right.
Yes, because they were cut. So in this experiment, the cuts were, okay, so you have equal contour lengths in the non-arbitrary case, and the same number of cuts as there are sort of loopy things to cut. So indeed, you get, the guys look identical. So the shape is overall arbitrary, but it's the same arbitrary shape repeated, which makes it non-arbitrary. That's why it would have been relevant for me to show you the prosada.
Yeah, so I just have this intuition that if you ask me to describe like a button, a scissors, and a book, that I'm less likely to use count nouns than for 3 books or 3 buttons or 3 scissors. Other things being equal, the naturalness of the contours being equated. Does that make sense? So the similarity within the set feels like it's an important variable here.
Yeah, no, 100%. So, so this is why it would have been important for me to show the prosada. So, they would present one of these arbitrary shapes in isolation and then ask people to choose, would you prefer to call it a blick or some blick, versus like a highly structured thing, and it comes out as you'd expect. The randomly shaped thing gets the mass noun, and the structured one gets the count noun. And then if you present the same arbitrarily shaped thing, multiple instances of it, now you get the plural language instead of the mass language. But if you present multiple instances which are differently shaped, preference goes back to mass again. Yeah, indeed. So there's something about, and actually there's a lot to say about this. Like when you, okay, so this is the point where I think these these guys that are too much kind of become useful. So whatever R is sort of the lexically specific content. That's filling in some property of whatever you're talking about. And then this guy here, so I'm a property of pluralities, every atomic part of which has that property, right? So ultimately it's going to be determined by what gets to count as, let's say, a concept, like an R kind of concept. If you had, like, say you took the array of like arbitrarily divided thingies and you told like some big story about, I don't know, like it's an explosives manufacturing facility or something, and these are like, there's something about like the thing, and then and people are going to be like, okay, that's like an explosive Xer or whatever. So that would be again an instance of, as long as there's sufficient sort of support for you to make the inference that it's an instance of the same category, then you'll be kicked into that land.
Unfortunately, we are actually out of time.
I'm sorry. My fault. I'm sorry.
So we're going to take a break for, what did we decide, 4 minutes? 4 minutes. We are going to take a 4 and not 5 minute break. And let's thank our speaker once more.
I'm really sorry.